This is part 1 of the Permanent Magnet Synchronous Motor Control series with Professor Duco Pule, Simulation for Voltage Mode Control.
All right, so we're going to be talking about the voltage frequency control of the converter. So we're going to basically be looking at that model. This is the first model in simulation. So here we have a very basic machine. We recall that we are going to control the voltage vector, okay, a rotating voltage vector, just a rotating voltage vector, and we're going to create that with a control machine, which is this machine here. So if you look inside the voltage controller, all it really is just a basic controller, which is taking you the inputs, the per unit inputs, voltages and current, voltages here, the DC bus voltage, and it creates here the modulation indexes for the controller. And there's a frequency input, there's a ramp, so we change the frequency ramp, and integrator, that's all it is. And that gives you the cos and sine of the angles, which are projecting that reference frame. We talked about this DQ reference frame. And if we go back one level, these are the modulation indexes. They're multiplied by the bus voltage divided by 2. They're the voltages coming out. They are fed into this model of the machine, and these are the currents coming out, the torque and the speed. Now, in the bottom here, which is really what we're going to see here, will be a vector. We will see the voltage vector being created here, and the currents and the d-axis of that reference frame. And when we run this application, and we hit this one, you're basically now running this application. And if you look at this carefully, now you see here the d-axis, the blue is the voltage vector, and the red is the actual current. So the d is the axis which we've chosen, and we now have a voltage and a current of 1.5 volts, and this is the current. We are not controlling the current in this case, we are purely controlling the voltage vector. And the green is the reference, okay? So recall that what we did in this case here, we have a d-axis and we have a q-axis, and we've set the voltage vector in that direction. This is the v vector in that direction. And the current is response to it. It's up here. It's down there. So that's what we're basically trying to control here. This rotating vector is set by the frequency which we set. And that's what we do in this case here. This is the most simple control we can achieve. All right? And to do that, we can observe the waveforms. We've done that one. And we can see also in time, this is the speed, this is the ramp up speed, and this is 300 hertz. 20 hertz corresponds to 300. In this case here, and this is the actual current, the actual speed of the machine. And there we see the voltage waveforms, and there we see the current in actual values. So by looking at this, we can understand the behavior, and we should see exactly the same thing if you run this now on the machine running. But we cannot see, of course, the voltage vector. So to run it again, let me show you the effect of, for example, changing a voltage to, say, we change the voltage to 2 volts. 1.5, make it up to 2 volts. Okay, so if we do it 2 volts, we should see a voltage amplitude of 2 volts in this d-axis, and this coordinate system is rotating at a speed set by the frequency. And because it's rotating, that sets the speed of the machine also. And if we set a higher frequency, this will rotate faster. So now we should see this one in this direction at 2 volts. Let's have a look what happens. And again, we do this in the workshop. And here you see it. It is there, 2 volts. Do you see that blue vector? It's exactly 2 volts. Now, suppose I told you I'm going to put the d-axis to 0 and put a voltage in the q direction. So in other words, suppose I set the value for ud to 0, and I set uq to, for example, 1.5. What will the effect be? in that case? Well, in that case, we are saying this is the d-axis. We are going to put a vector now in that direction of 1.5. What does that mean? It means you're still creating a voltage vector, but it should be there, and the current will be up here. Watch what happens. So now we have a rotating vector, and look carefully. Now is the d-axis here, and there's the voltage vector is now at 90 degrees to the d-axis, right?